The Avacta Optim is a step forward in the development of biotherapeutics, simultaneously providing information about aggregation state, conformation and other stability indicating parameters, with parallel measurements of up to 48 samples in just a few hours. Its unparalleled ease of use enables a fast and easy way to prepare your experiment, load your samples and analyse your data. Optim 2 is a significant iteration in design, performance and usability and represents a new focus for the Optim platform. Considerable improvements in all aspects of the instrument can be seen, most significantly in the software, which has been completely rewritten from the ground up. The first step to performing your experiments is to start the client software. This starts the instrument simultaneously and presents you with a main menu focused around the most likely tasks you might wish to perform, whether it be getting a quick snapshot of your sample or loading something you've done or programmed before. We provide you with a selection of spectroscopic tools or application solutions pre-configured for a wide range of common experimental methods, each focused around getting as much stability information as possible. Each application is available with a range of thermal profiles, including stepped and linear ramps or isothermal experiments, where kinetics are monitored at a constant temperature. They range from measuring transition temperatures and aggregation temperatures to things as diverse as predicting relative surface areas using protein denaturing chemicals. In this case, we want to obtain a TM and aggregation onset temperature using a linear thermal ramp, so we choose this option to configure our machine with the recommended settings. We can then choose a project, provide some information so that we can refer back to this run in the future before going on to some bookkeeping. Creating records for the samples that we measure will allow us to analyse interesting features and trends about our samples when we perform the analysis on the data. Each collection of samples is called a set. We can group samples together in a sample set to use in an experiment. So for example, if we have a template screening set that we use all the time, we can program this in here and choose it from this menu. Here we choose formulation screen and add a protein to it. After changing the formulation, we simply select it from our list and either drag and drop from our available samples into our MCAs or add everything in the order that it is available. We then pick our ramp parameters, including start and stop temperatures, heating rate and any incubation time. This is then the best time to load your samples into your MCAs. Samples can either be prepared and loaded individually, or be prepared in a plate and loaded into the MCA using a multi-channel pipette. This is made easy by a bespoke loading tool. Once loaded, the MCAs are sealed to prevent evaporation, which is essential for low volume samples, and up to 3 MCAs may be loaded into the instrument per run, allowing experiments to be performed on 48 samples at once. With our samples prepared, we place our MCAs into the instrument and simply click Load Samples. We can then choose to either start with the default settings or tune the instrument parameters using a manual configuration, which we can then save. In this case, we will just use the default mode. After a short scan to estimate the duration of the experiment, measurements will begin and the spectra will appear on the screen as they are collected. The analysis software is a separate package that can be used to analyse data offline while at your desk or on the road. It is again built around 2 core uses: a flow-based application solution where we can choose our application and perform pre-programmed analysis with recommended algorithms, and an advanced ultra-flexible mode. In this video, we will concentrate on the application mode, where we make the same initial choice as in the client software. In this case, we choose the TM and aggregation onset temperature functionality. Our first step is to load data into the software, first by creating a study to collate any relevant information into one place, be it different analysis on the same samples or otherwise. We can then load raw data for analysis. The flow through the software is geared around generation of a report. We can have many reports in each study and edit each one individually. At each point throughout the analysis process, we can add any information or analyse content to our report. The first step in this analysis is to look at conformational changes in the protein via information from the fluorescence. We can see here our MCAs on the left. Hovering over each well will indicate that trace on the graph and also tell us what the sample is. We can click on each well or the table of results underneath to hide wells that we don't want displayed, or if the result is an outlier, right-clicking and excluding it will prevent it from affecting our analysis as we continue. We can display the graph as sigmoid data, as is standard for fluorescence, or if we are more familiar with calorimetric data, right-clicking on the graph will allow us to plot as differentials. Adding the graph and table of results to the report is as trivial as clicking the buttons. We always recommend reviewing each result individually to make sure that there are no false positives or negatives. Again, each graph can be reviewed showing a clear indication of the result and added to the report for record keeping. Our next analysis step will look at the correlations between different samples in our experiment. It will automatically detect any trends in the formulation and display the graphs as relevant, showing how changes in pH may affect the transition temperature or the tertiary structure, and allowing us to identify the most stable formulation for our protein. Continuing on allows us to look at aggregation stability, looking at the baseline level of aggregation in the samples and the onset temperatures with the same process as before. Our final step is then to review our report before exporting it and completing our analysis.